Always something in the shack. Anyway, okay, we've got the stream up and running again, so we are now live on the internet once again. My apologies for that initial problem. It's always an issue here, but we are now on YouTube, VK3CSJ, and also my Discord stream, and providing that the indicator on my vMix program stays red, I'll be streaming all the way through. Anyway, tonight there's a few articles, not many, but enough, I think, to fill up the hour. Just a little bit of Sky Notes from Timothy Hill's Sky Notes from the Planetarium, just to finish off the dates on the state thing. And then a little bit on the Lagrangian points, just a little article on that one. What are Lagrangian points? Something about, this is a leftover article from last week. The James Webb Space Telescope finds a spiral galaxy about 5 times more massive than the Milky Way. They call it the Big Wheel. It's a nice and short article. Something about using artificial intelligence cameras, infrared AI camera, proposed to scan the Earth skies for signs of alien visitors. I thought I'd just throw that in. And if I've got time, there's a little article here about using thermal nuclear engine to get to Mars, and then we go straight into space weather. Although I think, just we'll see how we go on that. Now, last Wednesday was the Astro Talk. The monthly ASV meeting, which wasn't held at the herbarium, but rather it was a online presentation, and I'll be running that after the session tonight via YouTube. Well, I may not run YouTube. I don't know. I'll make that decision, but no, I probably will. But also via the repeater, just this presentation from last Wednesday, which looked reasonably interesting. I didn't catch all up with it all, but I had a quick study of it just a moment ago, and I thought, yep, that's worthwhile running again. Because I missed it. I usually broadcast it on a Wednesday, but I just missed it, unfortunately. Completely forgot about it, in fact. All right, we're still hanging in there with the streams, so I'm very pleased to say. Let me just check we've got Steve, VK3SPX, and Mike, VK3XL, watching Discord. G'day, guys. The thing I like about Discord is that it is just less than a second delay between what you're hearing on 80 meters to what you're actually seeing on the screen. So as opposed to YouTube, which is up to 20-second delay. Okay. I think we shall just go into the usual blurb on the ASV. I normally do for those folks that are tuning in for the first time, which normally doesn't happen until halfway through the session. The Astronomical Society of Victoria was founded in 1922, comprises well over 1,600 members throughout Victoria, the other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night, and I think that's changed now. Meetings start at 8 p.m. in the Mulia Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. Those monthly meetings usually last for a couple of hours, with the aim to finish at 10 o'clock. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook, of which I'm reading this from right now as I speak. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible to members too. The Society also has a number of 200mm reflectors available for short period loan through the ASV telephone loan scheme. Regular Society Club night meetings are held at the Melbourne Observatory in the Ellery Suite in Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of small reflectors. Members are also encouraged to make use of the Society's country property, some located just near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre radio telescope, which members can access with involvement in the radio astronomy section, pleasant even to any radio astronomer that's listening. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors or team leads are provided in the yearbook. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra Bulletins, which are emailed out to members. So generally every other week there's a little email that's sent out letting people aware of what's coming up, latest events or changes to things. Please note that the ASV will conform to all the government health directives that occur from time to time. Thus, ASV events may be required to be cancelled, moved or postponed, and that includes things like fire bans that might prevent access to the site. So more information about the ASV can be found on the ASV website at www.asv.org.au, where it all will be revealed. Joining the Society is a fairly easy process. There is a link to the membership page, and it's all via PayPal these days, so makes things much easier. After about a week you should receive a members pack in the mail, which includes a membership card and all the information you need to know about ASV and how to access certain things. If you wish, you can write to the Secretary by addressing the envelope to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. So, like I say, the yearbook, this is published by the ASV. It's a fairly decent publication. It's a bit like an almanac. Just holding it up to the camera right now, but it's a beautiful publication, and it's full of astronomical. Try to flick these pages in front of the camera, just for the sake of doing that exercise. But you can see it's just full of information the optical astronomer would want to have if you are doing observations. I noticed that this is the latest crux that's come through. This is the actual newsletter, or magazine they call it now. Which camera am I looking at? In fact, I had the wrong camera before, but there'll be a camera there. So that's the latest crux. It's come in, a beautiful picture there of a comet on the front. And that is Comet C 2024 G3 Atlas, which was photographed on the 31st of January using a Canon 6D camera and a 200mm lens, and it was 15 by 30 seconds, 15 exposures at 30 seconds long, location Adelaide. And the photograph was taken by ASV member Michael Matazazo. Matazazo. It's one of those names that you just cannot pronounce. What camera you have? There's the camera. So that's a fantastic picture of G3 Atlas. Interested to note, Mark Ascario, the president, has made a comment to indicate that he says here, if you've recently visited the LMDSS, Leon Mao Dark Sky site, recently you've probably noticed a flurry of activity around the new 2 metre and 3.5 metre domes. And he says, we're thrilled to announce that the telescopes inside these domes have been fully installed and commissioned. And he says, once our online booking system is up and running, members can remotely access these telescopes from anywhere in the world. Inside the 3.5 metre dome, we have a 10-inch F5 AstroWorks Newtonium. And the northern 2 metre dome houses a Skywatcher Esprit 100. While the southern 2 metre dome features a 10-inch f4 AstroWorks telescope. AstroWorks are a locally made telescope by Sidereal Trading, and basically engineered by Diego. I forgot his surname right now, I can't think of it, but it's all made locally at their factory, and he's an absolute magician when it comes to mechanical engineering. He has quite unique lathes and laser printing equipment for etching into the aluminium, from what I've seen. So AstroWorks, check it out. Go to Sidereal Trading online and in Telemarine there, and AstroWorks, type in AstroWorks in the search engine, and or when you visit the Sidereal Trading site, and you'll learn all about what AstroWorks is all about. They make some very nice telescopes indeed. Now, okay, that's that bit of a plug. You're tuned to ASV Radio, VK3EKH. The latest planetary report has come through. I'm a member of the Planetary Society, have been for a while. Unfortunately, my magazine's got a little bit wet. I don't know whether it's rain got into the you can see how stiff the paper is. I don't know whether it's rain or whether it's something else. But all the pages are stuck together, which is a nuisance factor. So you can hear how what the sound of wet dried paper sounds like. It's a bit of a shame. Yes, this little article here on computing in space, exploration history. What's this? In everyone's pocket right now is a computer far more powerful than the one we flew on Voyager. They say here, I don't mean your cell phone, I mean the key fob that unlocks your car. And they've got a photograph here of the young lass that was involved. Software engineer Margaret Hamilton stands next to a stack of written code for the Apollo guidance computer in the photograph taken in 1969. I think some of us have seen this picture. She's a software engineer, Margaret Hamilton, and she's standing next to a stack of written code for the Apollo guidance computer. And I'll just show that picture there if you haven't seen it before. There it is. There's this stack of code, and that marvelous young woman who was involved with the programming of that. Look at what was required for the Apollo computer to follow certain things. Rather remarkable stuff by that young lady. Excellent stuff, isn't it? But that's in the latest Planetary Society magazine. And yeah, it's a great little publication with a lot of information there. Anyway, there it is. Okay, I'm wasting time. It's 10:18. Okay, we're still there, still streaming, which is good. We also have an email address, vk3, vk3ekh@gmail.com, vk3ekh@gmail.com, if you wish to send a signal report. Just changing cameras here. That's a little bit off me, isn't it? That's better. Okay. Just checking things. We have no. Oh yeah, group. G'day, Bruce. Bruce is there on Discord, and I should check the chat room as well, I suppose. Just the same old. Mike, Stephen, Bruce. All right, fair enough. Now, where am I going to now? Sky notes. All right, there's just a few dates. Okay. Today is the 11th, so I'll just dart ahead a few days. I think I got up as far as Hubble. Oh yeah, I'll start from there. On the 21st of April 1990, the Hubble Space Telescope was launched on the Space Shuttle Discovery. On the 23rd of April 1992, COBE satellite, COBE, reveals microwave temperature variation across the universe. On the 27th of April 2002, the final telemetry was received from the probe Pioneer 10. On the 28th of April 1900, the birth of Dutch astronomer Jan Oort, whose name is given to a vast cloud of icy objects thought to orbit the Sun well beyond the Kuiper Belt. Also on the 28th of April 2001, American Dennis Tito became first space tourist, paying the Russian Space Agency $20 million US to travel on a Soyuz craft to the International Space Station for an 8-day journey. 20 million for an 8-day journey in space. I suppose if you got that money, okay. And then finally, the last date here, on the 30th of April in the year 1006, and that's right, it says here 1006, I don't think it's a typo. The brightest supernova ever recorded is seen in the constellation of Lupus, in the year 1006. Okay, let's move on. You're tuned to ASV Radio, VK3EKH. And we are still streaming, I think. I'm just checking those streams. I don't trust them. What are Lagrangian points, in case you were wondering that? This is courtesy of astronomy.com. The Lagrangian equilibrium stability points are places where the combined gravitational forces of two bodies produce regions of gravitational balance. And there's a little graphic for this. So let me just bring up this graphic. Okay. The story goes, the Lagrangian equilibrium stability points, or L points, are the 5 places where the combined gravitational forces of two bodies produce regions of gravitational balance. These are little pockets where other bodies can, in theory, remain orbiting in place without expending much energy. 3 of these L points, L1, L2 and L3, along the line connecting the orbiting body and its apparent body. L1 is located between them. At a point closer to the orbiter, I say full stop. I'm mucking around with the sentence here, sorry about that. L1 is located between them at a point closer to the orbiter, full stop. L2 is on the far side of the orbiter relative to the parent, and L3 is on the far side of the parent relative to the orbiter. You'd have to be looking at this diagram. The other two, L4 and L5, move along the path of the orbiting body, 60 degrees ahead of and 60 degrees behind the orbiter. The L4 and 5 points could each mark the apex of an equilateral triangle, with the parent and orbiter marking the other 2 points. You see, definitely would have to be looking at the diagram in this description here. In his 1972 paper, which is some Latin word here, and fortunately there is an English translation. It's Italian or French of some sort. I'm not going to try it. In his 1772 paper called Essay on a Three-Body Problem, Italian-French mathematician Joseph Louis Lagrange mathematically determined that such stable points could exist within an orbiting system. At the time, these points were merely theoretical constructs. In 1906, however, astronomer Max Wolf at the observatory in Heidelberg, something like that. What is that? Heidelberg. It's Heidelberg. In Germany, discovered the asteroid 588 Achilles at the L4 point in Jupiter's orbit. Within the next year, 2 other asteroids were found at the Sun-Jupiter L points. The asteroid 624 Hector was observed at L4, and 617 Patroclus was discovered at Jupiter's L5. Soon thereafter, the prolific asteroid discoverer Johann Palliser suggested that asteroids at Jupiter's L4 and L5 points he named for heroes from the Trojan War. The asteroids at L4 for Greek figures and those at L5 for Trojans. Despite this convention's adoption, this is not true of the names for all 4,601 asteroids now known to exist at L4, nor the 2,439 at L5. Additionally, by this convention, Hector and Patroclus are in the wrong camps, they say here, and so are sometimes referred to as spies. Today, all bodies located at the L4 or L5 points of any orbiting body are known as Trojans. Astronomers have so far only found 2 Earth-Sun Trojans in 2010, TK7 and 2020 XL5, both of which are located at L4 point. Note that the L1, L2 and L3 points are not stable over a long term. L4 and L5 are stable provided that the mass ratio between the apparent and orbiting bodies exceeds 24.96 mass ratio. That certainly holds for every planet-Sun pair in our solar system. Although the other points are less stable, spacecraft have been deployed to them. For instance, the Solar Heliospheric Observatory SOHO satellite is currently in a halo orbit around Earth's L1 point. Located at 1.5 million kilometers from Earth in the direction of the Sun. And of course, NASA's James Webb Space Telescope and the European Space Agency's Gaia probe are currently in orbit around the Lagrange 2 point, which is 1.5 million kilometers from Earth. but on the far side of the Earth relative to the Sun, full stop. As L1 and L2 are stable only over a short term, up to about 23 days, these spacecraft have to undergo periodic course and altitude corrections. All the same, these L points are prime locations for spacecraft, as they don't need to expend great quantities of fuel to maintain their positions there. No space agency has bothered to send any craft to L3, and there are no natural bodies around that point. The popular science fiction convention that the secret planet lurks there seems highly unlikely, because L3 is just simply unstable. So an object as massive as a planet would not be able to remain there for very long. Courtesy of Astronomy.com, under the tab Ask Astro. I think it is Ask Astro. I'm pretty sure it is. Alright, you're tuned to ASV Radio, VK3EKH, time 10:29. Last week, the James Webb Space Telescope found a spiral galaxy about 5 times more massive than the Sun. Let me just bring up that graphic picture. It's a bit blurry. Not sure why it should be so blurry. Maybe it's because it's so far away. I don't know. Anyway, so scientists are calling it the Big Bang. The Big Wheel. It existed just 2 million years after the Big Bang. Well, there it is. I knew the Big Bang had something to do with it. So in this photograph you're seeing on the screens right now, let me just check if I'm still streaming. Yes, I am. The James Webb Space Telescope image, this image you're seeing is the James Webb Space Telescope of the Big Wheel Galaxy, a massive rotating disk 11.7 billion light years away. Its spiral stretches 100,000 light years, making it the largest confirmed galaxy of its time. Thereby, nearby galaxies appear as blue blobs in this image, with a larger galaxy to the lower left, which is part of the same structure, apparently. Anyway, this article is not too long. No, it's not too long. To continue on, a team of astronomers at the University of Milano Bicocca has uncovered a colossal spiral galaxy that existed... Oh, don't touch the microphone, Clint. That existed just 2 billion years after the Big Bang, which gave birth to the universe some 13.8 million years ago. Nicknamed Big Wheel, it is in fact one of the largest galaxies ever observed from this early cosmic era. The scientists have found Big Wheel near a quasar, which is a powerful and active supermassive black hole, and using the James Webb Space Telescope, the galaxy lies 11.7 billion light years away from our corner of the cosmos, and is given the nickname. The given nickname comes from its remarkably fast rotation and huge size. It's 5 times more massive than the Milky Way, and for context, stretches across 100,000 light years, as already mentioned. More specifically, the astronomers used a new spectroscopic observation, which the James Webb Space Telescope's near-infrared spectrograph, or NIR spec, to confirm that Big Wheel is a rotating disk. The galaxy's rotation curve, an important characteristic of spiral galaxies, shows a pattern typical of flat rotation curves seen in mature galaxies. The velocity of the galaxy's rotation increases as you move outward from the center, reaching a maximum rotational velocity of several hundred miles per second, which is also similar to much more developed galaxies. They go on to say that the Big Wheel's rotational velocity also aligns with the local Tully-Fisher relationship correction between the size and rotation speed of galaxies observed today. What this all means is that despite its youth, The galaxy behaves in a manner consistent with some of the largest, most mature spiral galaxies we see in the present universe. Big Wheel exists during a time when most galaxies are expected to be small and in the earlier stages of development, yet it is fully formed, they say here. This galaxy is spectacular for being among the earliest, or the largest spiral galaxies ever found, which is unprecedented for this early era of the universe. One potential clue, they ask here, how could this happen? One potential clue lies in Big Wheel's environment. The galaxy resides in a dense region of space where galaxy number densities are more than 10 times higher than the cosmic average. This dense environment could provide the perfect conditions for rapid galaxy growth. Sebastiano Cantalipo, a co-author of a study, suggests that Big Wheel may have benefited from efficient gas accretion, which carried the coherent angular momentum necessary for the formation of larger disks. Additionally, the frequent mergers of gas-rich galaxies in this crowded region may have contributed to its massive size and rapid growth. We think this may open the door to understanding how some galaxies were able to bypass the usual slow process of star formation and grow to enormous sizes in the early universe. The discovery suggests that galaxy formation might not be as slow as gradual as previously thought, especially in environments rich in gas and emerging galaxies. Big Wheel challenges current cosmological models. Its size and mass far exceed predictions for galaxies at similar redshifts, making it an outlier in the galaxy population. Down the line, astronomers may need to adjust their models to account for the possibility of rapid galaxy growth under such dense conditions. And the study was published on March 17 in the journal Nature Astronomy. Okay, so that was courtesy of space.com. JWST finds spiral galaxy about 5 times more massive than the Milky Way. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. Science Alert. Okay, let me change the image. I've got to keep remembering that I'm doing that. This next article starts off with this image. Here it is. Okay, this is published 10th of April. 10th of April on www.sciencealert.com. I think we're all still there. Yep. Infrared AI camera proposed to scan Earth skies for signs of alien visitors. Well, bear with me on this one. This picture just on the screen at the moment is a reconstructed trajectory data points of studied objects. Right. In 2021, the Office of the Director of National Intelligence, ODNI, released a report detailing recently declassified information on unidentified aerial phenomena, UAP. Since then, the Department of Defense has released annual reports on UAP through the All-Domain Anomaly Resolution Office, or AARO. Nevertheless, there is still a lack of publicly available scientific data. Go figure. To address this, a new study led by the Harvard-Smithsonian Center of Astrophysics, CFA, and the Galileo project proposes an all-sky infrared camera, or DALEK, D-A-L-E-K, to search for potential indications of extraterrestrial spacecraft. The study was led by Laura Dominine, a member of the Quito Galileo Postdoctoral Fellowship at Harvard University and a researcher with the Galileo project. She was joined by fellow researchers from the CFA, the Galileo Project, the Whiten Observatory, and the Scientific Coalition for UAP Studies, and Atlas Lens Co. The paper summarising their proposal was presented at the 2025 Lunar and Planetary Science Conference 2025 LPSC, which took place from March 10 to 14 in the Woodlands, Texas. The instrument they describe in their paper is nicknamed Dalek, D-A-L-E-K, given its resemblance to the machine antagonists from the Doctor Who franchise. And I'll bring up that image right now. Let me just find it. There it is. Whoops, missed it. There we go. Okay, this is what we're talking about. Doctor Who. The instrument builds on recommendations made by NASA in a 2023 independent study where they stated, purpose-built feature sensors for UAP detection should be designed to adjust on millisecond timescales to aid better detection. In lockstep alert systems should detect and share transient information quickly and uniformly. Multi-sensor platforms are important for providing a complete picture of a UAP event, and object's motion should be recorded, as well as its shape, imaging data, colour, multispectra and hyperspectra data, and any sounds and other characteristics by that device you see on the screen there. Under this article, under this picture, it says that on the left is the mechanical design drawing of the Dalek, IR camera and array. On the right is the photograph of the Dalek as constructed at the development site. So one left is a diagram and right is the actual thing. Their paper details this multimodal, multispectral, ground-based observatory, the first instrument to undergo commissioning at the Galileo Institute's development site, and the calibration process. Professor Avi Loeb, the Frank B. Barr Jr. Professor of Science at Harvard University, the Director of the Institute for Theory and Computation, 2007 and to present, within the CFA, is also the head of the Galileo Project, 2021 to present, as he told in the Universe Today via email, quote, often US government data is classified either because it was collected by classified sensors or because it is not fully understood and could potentially be relevant for national security. When in doubt, the data is not released to the public or the scientific community. However, the sky is not classified, and so the Galileo Project is operating in an all-sky observatory at Harvard University and constructing two other observatories in Pennsylvania and Nevada that are searching for anomalous objects in the infrared, optical, radio, and audio bands. Unquote. As Loeb detailed, these three observatories detected about 100,000 objects per month. Each have already obtained data on about 1 million objects. This largest database systematically assembled on NEOs, which the Galileo Project analyzes using machine learning software. This software consists of a You Only Look Once model for object detection and a simple online real-time tracking algorithm for trajectory reconstruction. These algorithms are trained on familiar objects like planes, drones, balloons, birds, and satellites, etc., which allows them to sort through all observed UAPs and detect outliers. In addition, the paper contains a rundown of the observatory's first 5 months of operation. As the team stated in their paper, roughly 500,000 objects were detected in this period. About 16% of the trajectories they reconstructed, 80,000 were flagged as outliers at a 95% confidence level and manually examined with infrared images. From these, 144 trajectories remain ambiguous, which they state are likely mundane objects that cannot be further classified without information, and like distance and other sensor data. Loeb said, quote, "In the first 5 months of commissioning, data reported in this paper, we studied 500,000 objects and assessed our ability to classify them without distance information. In the future, we hope to measure distances to objects based on triangulation by multiple detectors spaced apart within each observatory. This will allow us to determine the velocity and acceleration of various types of objects and clearly identify anomalous ones." Close unquote. So, finally, by comparison, classified studies performed by governmental agencies such as the AARO, which can often leverage distance estimations from radar data and multiple sensors, reported that 3% of the cases brought to their attention remain ambiguous. "The ultimate goal," said Loeb, "is to find the few, if any, outliers that could be considered evidence of a technology-advanced species." Technosignatures. Loeb said, quote, "Our goal is to check if there are any objects which display anomalous flight characteristics or shapes. Even if 1 in a million happened to show abilities beyond human-made technologies, it would constitute the biggest scientific discovery ever made. And there it is. Such an object could suggest the existence of extraterrestrial technological civilization from which we can learn about more advanced science and technology than humans developed over the past century." So there's the key little word in there. It would constitute the biggest scientific discovery ever made. So despite all the people that claim to have seen UFOs, despite all the supposed evidence of seeing UFO, and there's no evidence, to be honest, we haven't found, there are no such things as UFOs. So we are on this planet all by ourselves. My opinion. I used to believe in UFOs a long time ago, but I have never seen anything that has changed my mind. And none of this stupid footage that you see in these blasted programs that claim fast objects, all taken with infrared cameras and heat sensing cameras, it's just woeful. There's nothing there that you can possibly say, yes, that was of extraterrestrial existence. So hopefully this project that's starting, this infrared AI camera proposed to scan Earth's skies for signs of alien visitors, might come up with something. I bet you it doesn't. You're tuned to ASV Radio, VK3EKH. The time is, what is that, 13 minutes to 11. All right. This is just a nice short article, thank goodness, and I shall get rid of that picture on the screen there and put up this one, which is a pretty ordinary graphic. I was almost not thinking about putting it up because it's so horrible. It's just a horrible graphic. Somebody just slapped some pictures together and thought that'll do. Wouldn't it bother you? Let me see, where's the article again? The thermal nuclear engine, and I could go all political here, but I won't. The thermal nuclear engine that could get us to Mars in just 3 months, published January 27, 2025. So it's a bit old, only just by a few months, but I've only just discovered it. This is courtesy of www.physics-astronomy.com. So I suspect there is some sort of belief to all this, accreditation, whatever. Okay, as the article says here, As it's so close to Earth, Mars is the planet that humans will most likely step foot on and explore first. And if it's the last thing that I see on my deathbed, I want to see man step foot on Mars. If it is the last thing I see. Ultra Safe Nuclear Corporation, USNC, has introduced a groundbreaking thermal nuclear engine design that could drastically shorten the time it takes for astronauts to travel to Mars. This innovative engine could carry a crew to the Red Planet in just 3 months and return them to Earth in the same amount of time, cutting current travel estimates by half. This is made possible by USNC's use of high assay, low enriched uranium, or HALEU, HALEU, assay. Use of high assay, low enriched uranium. Let me just have another swig of coffee here. I need a little bit more caffeine. So just repeating that sentence again. This is made possible by USNC's use of high assay, low enriched uranium fuel in ceramic microcapsules, which allows for a lighter and safer nuclear reactor, specifically designed for space travel, of course. The concept of nuclear propulsion has been around for decades. While the use of nuclear reactions to generate immense heat is well established in weapons, it has yet to be fully realized for spacecraft propulsion. Past designs lingered in the experimental phase before being abandoned, though they have been revisited occasionally for further research. Unlike chemical rockets, which are liquid oxygen or similar propellants to create combustion, nuclear thermal engines use the heat from nuclear reactions to push rockets at far higher speeds. This advancement brings nuclear-powered rockets closer to the speed required for efficient space travel, making Mars missions more feasible. USNC's thermal nuclear engine design arrives at a pivotal moment shortly after Elon Musk suggested that nuclear propulsion could be critical for ensuring astronaut safety during space missions. Musk's primary concern is the health risk posed by prolonged exposure to cosmic radiation during space travel. A faster trip would significantly reduce the time astronauts are exposed to this dangerous radiation. The Department of Energy has also weighed in on the safety of the HALEU fuel. Although handling nuclear materials always carries risks, the HALEU is considered to be less dangerous than many other nuclear options. Moreover, cosmic radiation exposure during a long journey to Mars is likely a far greater threat to astronauts' safety than handling the HALEU fuel. USNC's nuclear thermal engine builds on existing nuclear technology, particularly its micro-reactor systems. While USNC is divided into two divisions, USNC Tech, focused on space reactors, and USNC Power, focused on terrestrial reactors. Both divisions share common technological goals, of course. The same ceramic encapsulated HALEU fuel used in USNC's nuclear thermal propulsion system will also be used in its terrestrial micro-reactor energy facilities. This overlap allows USNC to apply advancements in nuclear technology to both space and Earth-based systems. According to USNC's Tech CEO Paolo Verini, The ability to transfer nuclear technology between terrestrial and space applications is key to the company's success. Their nuclear engine is designed to provide twice the thrust of traditional chemical engines while offering improved stability, thanks to the encapsulated fuel. This increased thrust is crucial as chemical rockets have nearly reached their maximum efficiency and capacity. To move beyond the limits of chemical propulsion, nuclear technology is seen as the most viable path forward. In conclusion, USNC's new nuclear engine marks a major step toward more rapid and efficient space travel. If successful, this technology should revolutionize how we explore distant planets, potentially bringing human mission to Mars within reach. With its combination of safety, speed, and stability, nuclear propulsion could be the key to unlocking the next era of space exploration. Well, there it is. That's just the next step to the ultimate Star Trek warp engine, but this will do for the time being. Anyway, that article is found. Let me just change the camera here. Go back to this one. The microphone's in front of my face. It's good enough. Where was it? Oh, yeah. The website for that article was www.physics-astronomy.com, and the title was under the Astronomy tab, titled The Thermal Nuclear Engine That Could Get Us to Mars Just Within 3 Months. There it is. Time is 5 minutes to 11. And let's pop into this. Hang on a second, let me see. What else was I going to do here? Just a bit of a plug for. Oops, going the wrong way here. Astrophiz.com. Let me bring up the latest episode. Where are we? Where is her picture? There's a picture here somewhere. There it is. Bring that up. Okay, so Astrophiz episode 210. Professor Elizabeth Tasker, involved with the JAXA sample return mission. And I think I've left a web page open where we just talk about her briefly. Have I? Oh yeah, there we go. Okay. So Brendan O'Brien, who hosts the astrophiz.com website. Good on you, Brendan, if you're listening. He says that you'll be astounded when you listen to Professor Elizabeth Tasker. I don't know what the A is. A/Professor A. Don't know what that is. Sounds a bit funny. Might mean something, I'm not sure. You'll be astounded when you listen to Professor Elizabeth Tasker as she takes us on an astonishingly brilliant 600 million kilometre roller coaster ride on the JAXA Hayabusa missions to collect the very first asteroid samples and bring them back to Earth for analysis to reveal the primordial origins of our solar system. You'll marvel at this triumph and ingeniously designed and executed science and engineering. Elizabeth also gives us an update on JAXA's 2026 Mars Moons mission. The MMX Great Science Stories of Discovery are essentially great human stories. So that podcast is now available to listen to. Just go to astrophiz.com. That's Astro P-H-I-Z, astrophiz.com, and look for episode number 210, which will be pretty much at the top there. Elizabeth Tasker, JAXA sample return missions, and that's her on the screen as I speak. Spaceweather.com. Let me see. Go back to there and bring up the sun. Here comes the sun. Where is the sun? I didn't bring it across. Why didn't I bring that across? There's always one image I don't bring from my picture file. Image, browse, pictures, AS3 broadcast. There it is. Click on that. Open. and OK it, and there she is in vMix, and there she goes. Alrighty then. The solar wind is currently at 475 kilometres a second. It is blowing a gale at a density of 1.94 protons per cubic centimetre. The disk of the sun, as you would see it right now if you could look at it through the safety of an appropriate telescope, gives you a few sunspots. It's not as busy as it has been, but there's a few sunspots there. The current sunspot number is 112, and the radio sun, the current radio flux, measured at a wavelength of 10.7 centimetres, is 153. The Aurora Australis is currently active, and I've got an image here. Let me bring that image up. So that's the current photograph of the Aurora. Yep, hasn't changed too much in the last hour. So it's a little bit of activity there, but not much to write home about, as I say. There wouldn't be too much seen from the mainland, I don't think, with that. The coronal hole. Corona hole. There is a coronal hole, and that's it's marked there. Well, you can see it in this image at the bottom. So solar wind is currently flowing from this southern coronal hole, which could reach Earth on April 11 and 12. And they say here that geomagnetic storm watch. NOAA forecasters say that a minor G1 class geomagnetic storm are possible on April 11-12, when the CME is expected to graze Earth's magnetic field. The CME was hurled into space by an erupting solar filament on April 8. High altitude sky watchers should be alert for auroras mixed with nearly full moonlight. KP index. Where's the KP index got to? The planetary K index is now 2.33, which is considered quiet, but over the next 24 hour, it could reach to 4.33 and considered unsettled. But currently, it's considered quiet, 2.33 for those planetary K index people. And there's just one more thing here. For those watching the vision side of it, this is the current solar cycle. I've got it here somewhere. There it is. All right. So as you can see in the image there, the top is the solar cycle sunspot number, whilst the below graph is the radio sun, the radio flux measured at 10.7. The radio flux and the solar cycle virtually mirror each other. And as you can see in that image, the peak of the solar flux is pretty much peaked. And if you go by the trend, it's now trending downwards. Not to say that that is the end of the solar activity. There's bound to be plenty of solar storms, solar flares, and of course great communication conditions on HF. For the next, you're looking at the next 12 months to 18 months or so of good propagation on HF from time to time. I think that's about it, although there is one more thing in this article on spaceweather.com. I'll bring up the image that I've saved here. Right, now this is briefly an eruption on Comet Swan. A newly discovered comet, Swan C 2025 EF2, that is just F2, just underwent a significant eruption. Astronomers Mike Olson who has been observing the comet almost every morning from Tucson in Arizona, captured the event. And in this image here, so on April 3, it's pretty ordinary. On April 6, you get what looks like a tail. April 9 is something else, and April 10 is... Oh, I see. Okay, so it's not so much the tail that you seem to see here, but rather the actual size of the light that's gathered. Let me read the article. They say here that Comet Swan underwent a significant eruption. For those who have wondered why Comet Swan has been so hard to observe the past few mornings, it is because the comet has faded in magnitude since reaching its brightest point several days ago. Sometime between April 3rd and April 6th, the comet had a major eruption, which increased its brightness by a factor of 4 to magnitude 8.4, which is what you can see in these images on the screen. The eruption may have been a pocket of ice exposed and explosively vaporized by the intensifying heat of the sun. Since the comet has faded by a factor of 2 to stabilize around magnitude 9.3 in the past few mornings, he says here that it will brighten again. The comet is falling toward the sun for a close encounter inside the orbit of Mercury on May 1. Standard light curves suggest it will eventually glow as brightly as a 5th magnitude star, giving it an easy target for small telescopes and binoculars. Additionally, eruptions could shake up that prediction, however, so stay tuned, as they say here. So that's Comet Swan. That's in our skies at the moment, and I think that's about it. As of April 11, there were 2,349 potentially hazardous asteroids, but none of those asteroids are on a collision course with Earth. Okay, that's spaceweather.com. I think on that note, we shall go to a camera. This one here will probably do for the moment. And we'll finish that up. It looks like my streams have held in there. Let me just check. Oops, don't do that. Let me just check Discord and see if there's anybody in the chat room there. Nobody else is really added there. Our chat rooms used to be quite busy there, but it's been quiet. Anyway, I can see Andrew's there, VK3KIS. G'day Andrew, Bruce, Steve and Mike. G'day guys, are still hanging in there with the pictures. The YouTube stream is still hanging in there, but that's likely to fall over as soon as I start doing the callback, which will include Discord, so my apologies in advance. And the email, let me just check email. The only email is from Andrew. He says, just listening on 80 meters, 5 and 9 with little band noise. Thanks, Andrew. Good on you. All right. Yep. Yep. Nothing that'll do for the moment. I will follow this broadcast. I won't broadcast it on 80 meters, but I'll continue on once I finish doing the callback. I'll continue on with the Friday with Wednesday night's Astro Talk. I think I've got a slide here. Actually, I'll bring up the slide. So last Wednesday night on the Astro Talk for April, which was done online, is how can indigenous astronomical knowledge guide modern astrophysics? It's a presentation by Duan Hamcha. Duan Hamcha, I think that's how you pronounce that. Anyway, I'll run that. As soon as I'm finished, I'll continue on with the A2V repeater and the YouTube and the Discord stream for that particular talk, because I've had a quick scan of it, and there's some very interesting imagery and very interesting discussions being made by the presentation guy. So I'll run that. So if you want to hang around for a little bit afterwards, you can catch up with that on YouTube and Discord and the TV repeater. And that'll be followed by just a 13-minute rundown of what's in the sky for the month. Bill Stent would normally do that, but he's crook at the moment, so it's presented by our ASV president, Mark Ascario, as best as he can do. I've heard a little bit at the beginning, so good on you, Mark. Anyway, all right, let's open up to a quick callback and see who we have that's prepared to call in. Let me just get my pen, see if it's working. All right, and I'll open that up. Hang on a sec. Let me just press a few buttons here. And turn that on, and that should bring audio into the digital realm. This is VK3EKH with his headphones off. Gee, that feels funny. Listening on 3541 kHz for any stations wishing to check in.
VK3GL, VK3SPX.
All right, we've got VK3GL, VK3SPX. Anybody else? Well, that's fine by me. They're all watching the footy, and I think the footy's over now anyway. All right, VK3 Golf Lima, VK3 EKH. Go ahead, mate.
Yeah, g'day, Cliff, and good evening to others, one and only, that have checked in this evening. A very quiet list tonight there, Cliff. Anyway, a very pleasant good evening to you from sunny Bunyip. Good signal here on 80 metres tonight, no problems at all. All copied on the broadcast. I didn't watch anything. I still haven't worried about getting the stream happening again. I think I mentioned to you there was some issue with having access to Discord, and I haven't bothered with it at this stage. Yes, the footy's finished. Collingwood won. And I just had a bit of a scan around. There's a classic movie on the moment. It's called, on Foxtel called Spartacus. I've got that going in the background. Anyway, look, thanks very much for the broadcast tonight. I have been a bit busy engaged with work things tonight, so I only caught bits and pieces along the way. I wonder whether or not you've had any update on the home front for the dome. I think last time we were talking about that, there was some discussion about the fellas having to go to South Australia or something like that. So I don't know whether or not you've got any further updates in terms of a prospective date to have it installed. All right, with that, I'll put it back to you, and thanks again for doing the broadcast, as always. Even if I don't get to listen to it all, and I only catch bits and pieces of it, there are some learnings along the way. VK3EKH, VK3GL.
Right, 1, 2, 3, 4, 5. Oh, there we go. Sorry about that. That's my microphone playing up. I don't know what's going on, but here I am talking about crackly headphones. Like I said, you hear this noise. And there's a rattle. Hear the rattle? That's a loose speaker in these horrible Texan microphone headphones. It's about time to get a new pair of headphones, I suspect. Sennheiser used to make good headphones, the ones that encapsulated your ear. I always hated the Sennheiser headphones that had the yellow foam that pressed against your ears. After 15 minutes, the pressure on your ear really hurt. Much better to have headphones that encapsulate your ears fully. Enough of that rubbish. Thanks, Graham. Thanks for calling in. See you next week. Yeah, look, you're going to have to do something with Discord and get that all sorted out. So look. The only thing I've heard about Discord is that when you're registering for the first time and you follow the procedure that they give you step by step, and you don't stuff up, and you use an email, and it's important to use an email address that's reliable and that you're going to be using all the time. And remember your password, because if for some reason you don't use Discord again for a number of weeks or months, and you forget all about how to log in, and that's it. That's a problem. If you forget how to log in, what username you used and what password you used, if you go through this whole process of re-registering, that's where things get a bit messy. So it's really important that when you're registering with Discord, that it's a once-off thing, and that you remember your username and password. Stash it somewhere where you can refer to it. Anyway, but I like Discord because I'm running a HD stream, which I'm paying for, because the SD stream is pretty ordinary. So it's something like $13 a month to have that HD stream on Discord, and it's and I can run it all the time. It doesn't chew up any bandwidth of any significance. I can just run it, whereas YouTube it's not really advisable to have a thing going all the time. Some people do, of course. Anyway, thanks, Graham. Oh, you asked about the dome. I think you're aware that the deck has been made. I finally got a builder to come in last week, and he has leveled the deck. He used a laser device. He placed the laser, this laser that produced a 360-degree beam, pardon me, on the concrete pillar, and he measured all four corners of the deck, and they're all out by significant amounts. So the very next day he came back, and by 8 o'clock in the morning he was working on it, and he spent most of the day leveling the deck, and it's absolutely level as. I've got this 2 meter spirit level. It's this big, and I went on all diagonals across the deck and parallel runs, and the little spirit level bubble was smack dab in the middle. It did not deviate. So so she is level, and there's new composite decking on it, so it looks really specky. And I've notified Sidereal Trading people that the deck is ready to be for the dome to be assembled on. So at the moment, Sidereal Trading has told me, sorry, I've just got an itchy nose, has told me that we're looking at about 4 weeks before they can slate me in, because Sidereal Trading have received a shipping container full of 3 meter scope domes, and basically they are orders for other customers, and the small team that goes out assembling the dome, flat out taking these domes to the customer and assembling the domes on their respective decks or concrete pads. And one of these domes is going out to South Australia, to some place in Adelaide or somewhere in South Australia. So that's so if you see a dome, a white dome on the back of a trailer, that'll be the team heading out towards South Australia. I think that's already been done actually. And there's another installation happening north of Melbourne at some grammar school or some university. But anyway, I've been told that they're going to try and slate me in towards the end of the month when they got some free time. So it is happening. It is happening thing. I will have the dome finally assembled and up and running and motorised and powered up, and there'll be a telescope out there, and I'll start being able to do some astronomy, and of course eventually we'll stick a camera on it and take some pictures. There it is. That's it in an update. Thanks, Steve, for your emails you sent to earlier in the week about all this. So I shall keep you definitely abreast of what transpires, and there'll be pictures coming. And I look forward to being able to set up a telescope in there at some point. So thanks, Graham. Across to you there, Steve. VK3SPX, VK3 EKH.
VK3EKH, this is VK3SPX. I guess you do realise that you're off there for a couple of minutes there just after Graham. Back to you.
Yeah, it was a microphone problem. That's what I said. I gave the microphone a big hit, and suddenly the audio came good. So all I was talking about was my noisy pair of headphones. So when I realised that nobody was hearing those noisy pair of headphones, I thought, hang on, I've lost audio again. So, yep, not a problem.
Yeah, no worries, Clint. Yeah, Graham and I had a little discussion about wondering what was going on there. We saw you waving the things about. Anyway, look, the deck's coming along great, Clint. That should be level enough for anybody, I reckon. You could play billiards on that, so I think you've probably exceeded the necessary specification for levelness there, I suspect. So let's hope that gets going soon. Some interesting things. The Lagrange points are interesting, aren't they? I just wonder how many spacecraft you can crowd around it. I guess it's not within 1 metre or something of the necessary distance. I guess that the spacecraft have the ability to manoeuvre and you can have a whole bunch of them, within maybe a few kilometres of the correct space. I'm just guessing, but interesting, isn't it? And I kept talking about the UAP detection with the Dalek. I said, are you sure that's not an April Fool's Day joke? I couldn't believe that. How much money are they spending on that? I reckon if Elon learns about that, they'll get the cut really quickly. But I bet they're all having a lot of fun with it. Yeah, it sounds like a fun project, but maybe they'll discover something else. But the chance of discovering some UFOs from some other civilization, I reckon that's about as close to zero as you're likely ever to get. Anyway, and the thermonuclear engine, I went down a rabbit hole there looking at that on the net, Clint, trying to figure out how they work and what have you. Interesting, isn't it? Apparently they just carry hydrogen or helium, which they eject out the back at, must be a phenomenal speed to get enough propulsion from the amount of hydrogen or helium you're likely to be able to carry. Yeah, interesting. So might be a little while before we perfect that, but should be good. All right, look forward to seeing more about the deck and get some photos there, Clint. Sounds great. Back to you, VK3EKH. This is the K3SPX.
Yeah, good on you, Steve. VK3SPX, VK3EKH, and yes, there's audio there. Dear, I don't know why my microphone's playing up. I mean, it's been absolutely okay all this time, so I'm not sure why it's playing up. It's always something here in the shack. Yes, look, I thought the same thing. I was reading this article on the the AI camera, and I think I got about a paragraph in, and I thought, hang on, let's check the date of this article, and it's actually the 10th of April. I'll just check it. Yeah, 10th of April. So it's an article on space on Science Alert, www.sciencealert.com. Science Alert, one word, sciencealert.com. And it's titled "Infrared AI Camera Proposed to Scan Earth Skies for Signs of Alien Visitors." Published 10th of April. So I thought, it's not a 1st of April thing. Yeah. Anyway, I'll keep an eye on that, because I genuinely think that there's a lot of objects, one way or another, that are flying through the sky, whether it be man-made aircraft, balloons, flocks of birds, or deorbiting satellites. And we've got so much crap orbiting this planet. There's a lot of objects up there that are deorbiting, and they can cause quite a significant. But that's obvious. You see something burning up in the upper atmosphere, and you know what it is when you see it. It's fairly obvious. So it'll be interesting to see what they come out of that. Um, I remember Carl Sagan in Cosmos talking about this. There was one of his episodes. He was involved in talking about various kinds of engines, and nuclear explosions was one of his. He showed grand drawings that had already been had already been drawn on the drawing board of these sorts of engines. And I always liked the way he used to describe that nuclear explosions that would create a kind of a put 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 sound. If you can just imagine Carl Sagan doing that in his exquisite way. We'll probably get there eventually, but it's a few things to overcome first of all, I think. Anyway, yeah, all very interesting stuff. Well, you heard it first here on ASV Radio. All right, and can concur about the pad as well, the deck. So yeah, look, each time I look out my window here, every time I drive home from work, I'm always looking into that corner where the dome is, and and now I'm seeing a finished deck, and I know it's all ready to go. So very, very soon, in a few weeks' time, I will see a completed dome there, and I'll be so pleased about that. Yeah. All right, it's 11:30. Is there any other stations wishing to check in before I disappear? VK3 EKH.
You had another 2-minute outage there, do you realise?
No, I thought I was okay. I've kind of been monitoring the audio, but I must have done something again. Oh well, all right. Thank you. All right, if there's no other stations, we shall depart the scene, and I shall go and pull apart this microphone and find out why I've got a grotty connection happening. Can't have that happening, can I? You have been listening to VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South. We're concluding transmissions on 80 metres, but I will continue with the vision for the next hour with the Astro Talk from Wednesday on... bring up that caption again. Oh dear, where did I put it? It's there somewhere. There it is. How can Indigenous astronomical knowledge guide modern astrophysics? Should be an interesting presentation, which I shall go into in just a moment. So this is VK3 EKH concluding. Everybody have a lovely week. It's going to be a nice summery week. Tomorrow is going to be over 30 degrees, including Sunday, I believe. And then the next few days are also going to be fairly warm. So it should be a last throes of summer. Cheers, everyone. Take care. This is VK3 CSJ, VK3 EKH with the K3 CSJ finishing on 80 metres. Cheers, everyone.
Thanks, Clint. VK3 clear.
Yeah, thanks, Glenn. It's going to be a wonderful day tomorrow, and a good day. I'm taking the SS out for a run tomorrow, seeing that it's going to be beautiful weather. It might be the last time that I get to do that before next summer, or at least next spring anyway. See you later. Cheers for now.
See you, Gray. No worries. Enjoy very much. I'm sure you will. Cheers for now. VK3 CSJ clear.
Yeah, it's always nice to get that out of the garage and go out. That's for sure. Anyway, cheers.
Righto. Oh dear, there's so much to do here all in one go. Too many buttons and knobs and things to do. Alright, I think there's audio there on TV. Let me just check. 1, 2. Yes, there is. Okay, let me just queue up this program. And actually not that one, this one. Okay, this is a bit of a night owl thing, so enjoy the next bit of program courtesy of the Astronomical Society of Victoria, Astro Talk, last Wednesday evening, presented by Mark Oscario, the president of the ASV, and the presentation on how can Indigenous astronomical knowledge guide modern astrophysics, presented by Duane Hamcha. I think that's how you pronounce his first name. Duane, D-U-A-N-E. Duane. I don't know. We'll find out in a minute. All right, let's kill my mic and run the program.
Good evening and welcome to the April Astro Talk for the ASV. This month we're going to hear from Dwayne Hamaker. Dwayne is an Associate Professor of Cultural Astronomy at the School of Physics at University of Melbourne, and tonight Dwayne will be talking to us about how we can all learn from Indigenous astronomy in the world of astrophysics. Following Dwayne's talk, we're going to hear from AI, Artificial Intelligence, Bill Stent, the telescope gent, because he's got COVID, which means you have to put up with me giving the tour of what's in the sky for April and May of 2025. Before we begin tonight's talk, just a couple of housekeeping items. We have the Mildura Star Party coming up on the Anzac Day long weekend up at Mildura. And we also have for ASV members, the Marangurk Star Party at the end of May as well. So members, you'll find the links for the Marangurk Star Party in the members side and also in Crux Extra. And for those of you who are not members, Mildura Star Party, great opportunity to get away from Melbourne for the long weekend and visit part of regional Victoria and enjoy some wonderful dark skies. For now, we're going to bring in Dwayne so he can present his talk. Dwayne, good evening. How you going?
Good evening. Thanks, Mark. I appreciate it. Everything working?
It is. We're ready to rock. So I'm going to hand straight over to you, Dwayne, and you can take it away. I'll pull myself back into the green room and the floor is yours.
Thanks a lot. Thanks, Mark. I appreciate it. And I appreciate the ASV inviting me to come and give this talk on how Indigenous star knowledge can guide modern astrophysics. Very controversial talk we're talking about tonight. I have been working in the space of Indigenous astronomy for about 16 years. I studied physics for my degree back in the US and came to Australia for the first time 22 years ago. And that set me on this curious pathway to where I am now. And over the years, I earned a master's degree in astrophysics, searching for exoplanets, and then I transferred my interests over to the world of Indigenous astronomy. And since doing my PhD in Indigenous astronomy, I have been focusing on unpacking the layers of scientific information encoded within these knowledges. So this is an interesting topic that I began doing because I heard a lot of Australians, a lot of people saying, Aboriginal people have no scientific knowledge. They have no capacity for any of that. There's simply some myths and legends and stories about stuff, but there's certainly no science there. Stupid seppos, what do you know? That kind of attitude. And with the eyes of an astronomer and with the background in physics, it's not difficult at all to see how much science is encoded, is embedded, and is shared within these knowledge systems and then passed down through various cultural traditions. We're going to unpack a little bit of that today, but what I want to focus on is how Indigenous star knowledge can actually guide modern astrophysics. And I think in this context, it's important to clarify this is something that the larger astrophysics community in Australia and around the world is very much taking on board. We just submitted a major center of excellence on an area of astronomy that's directly involving this. An Indigenous theme is a major component of that, including the research program. Not simply, outreach and education, which I love, but also the actual research side of this, how Indigenous star knowledge can guide modern astrophysics and how astrophysicists and elders can work together to not only better the culture of doing astrophysics, but to better understand our place in the universe and to actually guide astrophysical practices themselves. So keeping this in mind, this is something that the wider astrophysics community is a part of, is involved with this and is supportive of this. And I can assure you that if I were prancing around teaching airy-fairy astrology and stuff, they would not be supporting this. And that is not the case. So I think to give some context, this actually first part ties into a talk I gave a few years ago at the ASV, and I think it's worth reiterating. That there are a few major themes that come across in this research, and it's important to understand the context of Indigenous astronomy or Indigenous star knowledge and the Indigenous traditions through which it is passed down. So I want to start off by saying there is a difference between Indigenous astronomy and Indigenous star knowledge. And there is a difference between knowledge and traditions. So let's unpack that before we get into the stuff I'm talking about here on the screen. When we talk about sky knowledge, we talk about the cultural knowledge developed by Aboriginal and Torres Strait Islander people, and most any culture around the world, that's going to relate to things happening in the sky. Now, that isn't purely just celestial stuff. That can be weather and climate, clouds and things of that nature, meteorology, that kind of stuff happening as well. But it's part of what people here refer to as sky country. So people refer to the land on which they live, their local environment, as country. You can have land country, you can have sea country, and of course you have sky country. And that's all a system that is embedded within each other. No part of that can really be separated. And that's something that ties into what I'm going to talk about in a second. But it's really important to say there's that wider body of knowledge. There's also the more specific body of knowledge that ties into the actual knowledge and understanding of the stars, what we might think of as scientific understanding. That is indigenous astronomy, right? And I also use a little bit of a double entendre when I talk about indigenous astronomy. It is the astronomy of indigenous people, but it is also the indigenous astronomy, the astronomy that was around before the term astronomy ever existed. And for those who may wonder, well, did traditional people practice astronomy? Yes, absolutely. And there are names for those people who practice astronomy. I talk about in the Torres Strait, where I do a lot of the research that I do with communities. There they call the astronomer the Zugabal Mabaig. The Zugabal refer to the spiritual ancestors who became stars and constellations. And Mabaig is simply a Kalulagoya term for a man or a person. So it literally means star man or constellation man, constellation person, who goes through a number of years of rigorous training, starting off in their mid-teens, in the art and the science of astronomy and star knowledge, and continues that training throughout their adulthood. So I think it's important to give some context. When we throw these terms around, they all have a specific meaning, right? So indigenous astronomy and indigenous sky knowledge are distinct, but of course there's a huge layover because one comes from the other. But knowledge is the understanding we have about how things work in our world, whether we're looking up at the sky or looking down on the land. And the traditions are the ways in which that knowledge is practiced and or in which that knowledge is passed down to successive generations. So tying in with what I'm showing you on the screen here, the person on the far left is Professor Annette Lee. Annette Lee is a Lakota, Dakota woman from Minneapolis. She's a professional artist with 2 MFAs and a BFA, Bachelor and Master of Fine Arts. She's also got a bachelor's, master's, and PhD in astrophysics, and she's got a doctor of science. And she is the director of Native Sky Watchers, a professional organization dedicated to indigenous astronomy there in North America. And she, like every other elder I've ever learned from, say the same thing. Everything on the land is reflected in the sky. As is above, so is below. If you want to understand how things in the world around you work, you look to the stars. The stars serve as a map, as a directional aid, as a timepiece, as a clock. Stars serve as a mnemonic, as a memory space, as a canvas, storyboard on which you can, paint your stories and your art, your narratives, in which knowledge is encoded that you pass on to successive generations. If you want to understand animal behavior, you look to the stars. If you want to understand the plants in medicine, you look to the stars. If you want to see how the landscape is laid out, you can map that out in the stars. The stars inform everything that happens down here in our terrestrial world. In the middle here, we have an image of Professor Martin Nakata. He's the first Torres Strait Islander to earn a PhD. He's currently the Deputy Vice Chancellor at JCU up in Townsville. And he, said when he was young, he came to a crossroads in his life. He couldn't figure out if he wanted to pursue his degrees in education or in astrophysics. He chose education. He says he doesn't really regret it, but he always had that very keen interest in astronomy. And now we have been working together for well over a decade, to build up the space of indigenous astronomy. He's the academic who gave me my very first job when I came out of my PhD. And one of the things that he sat and taught me, which frankly I kind of already knew, but he had reshared this, is that we're a people of culture. Nobody really argues with that. But we're also a people of science. And this is something that some people just can't seem to wrap their head around, that there are people that understand how the world around them works. They understand that world around them through observation, through inductive and deductive reasoning, through experimentation, through trial by error. You have to figure out how things work and how to develop systems, how these things are interlinked together and how they relate together. And if your information is wrong, it's not just that you're wrong, it's that you could potentially die. If your community, food, navigation, whatever it happens to be, you're developing knowledge based on the world around you, and you get that information wrong, it's not a minor infraction, right? So in this context, he talks about we are a people of science. Now, I think it's important to mention that the world of what we think of as Western science that came out in the scientific revolution, we think of Copernicus and Galileo and Newton up through Einstein. We think of that body of knowledge, a larger body of scientific knowledge, and indigenous knowledges, right, plural, because every indigenous culture is going to have their own knowledge, their own ontologies, their own ways of understanding the world. When you look at them, they're not the exact same thing. You can't put an equal sign between them. They're two different systems of knowledge, well, multiple systems, but they're different systems of knowledge about understanding the world in which we live that are asking different questions, and they have different applications, right? But there is a crossover. If you were to see a Venn diagram, the Venn diagram is not going to be a perfect circle, but it's not going to be two separate circles, right? There is a crossover. There are ways in which those worlds interlink very closely together. That is the world in which I primarily work. And that is the world in which I'm going to be talking to you about tonight. So I think it's important to lay that out. When we talk about indigenous science, we're not equating it to Western science. We're showing there are ways of understanding the world around us, that they have similar foundational practices, and that they can inform each other in a lot of different ways. On the right here, we have a picture of Uncle Alo Tapim. He's one of the senior elders on the island of Mare in the far east of the Torres Strait. This is the island that Eddie Kweki Mabo was from. I'm sure you'd be familiar with Mabo Day, and his court case that overturned Terra Nullius. He talks about how your ability to thrive in your environment depends on your ability to read your environment. In this case, read the stars. So to be able to observe and interpret what you see in the sky and find meaning in that. So if you want to observe the changes in the properties and the positions of the stars, you can find a lot of important information out of that if you understand how to read it. So we're going to talk a little bit about today, how science is embedded within indigenous knowledge, but with the focus on how this can actually guide scientific practice. And one of the first things that's critically important that we understand is getting away from this idea that the two opposite ends in the spectrum are fact and myth. Myth is not the opposite of fact, right? I used to hate using the term myth or mythology because of all the negative connotations. And now I'm like, you know what? Screw it. We're taking it back. Myth means story. Okay. Mythology is the study of spoken stories. Myth is a mnemonic. Mythology is the way that we pass down information over time. And most cultures in human history have done this. The idea of structured written languages is a fairly recent invention in human history. I'm using history in the broad sense, not purely in the written record sense. But when we talk about mythology, mythology was meant to convey multiple layers of information, multiple layers of knowledge in a way that could be passed down to successive generations while maintaining vitality. So these stories have a lot of different layers of meaning that are embedded within them. There's going to be some scientific layers of information if you know how to unpack them. There's also going to be social lessons in there. There's going to be fable. There's going to be allegory, right? But the idea that, if you go back to, some arguments that, might be saying, oh, well, you're teaching myth as science. Teaching myth as science makes no sense because myth isn't the opposite of science. Myth is a mode of knowledge transmission. It's like saying you shouldn't teach a book as science. That doesn't make any sense. You can't teach a book as science. There's information in the book that can teach you about science or cannot teach you about science. Myth is the same way. Oral tradition, being the more preferred term that we use, is about how you can encode that knowledge in and pass it down. And that can include song and dance and art and a lot of other things. But the first thing you have to do is unpack what myth means and really understand the power of orality. And that when you hear about oral traditions, that doesn't mean they're just made up little stories. That is knowledge being passed on orally, and it's extremely powerful. And if you want to learn more about that, I highly recommend reading the books of Lynn Kelly, books like Memory Space, The Memory Code, and her new book, The Knowledge Gene, which unpacks the actual genetic foundation of how we as humans have the capacity to do that. So I want to get right into some of the fun examples of this. So when we're looking at certain areas of astrophysics, there are going to be areas in which indigenous knowledges are going to be able to inform them quite well, and there are going to be areas where they're not. That's just fine. Same goes, there are ways that astrophysics could help inform indigenous knowledges and ways in which it couldn't. But let's start to unpack some of the ways in which they can. So part of the research that I'm doing is on transient astronomy. So these are, everybody knows what transients are, short-term kinds of events. There can be a lot of different types of transient events, whether it's a comet or a meteor or even aurora. But in the terms of astrophysics, we're talking more about cosmic explosions. But you can have non-explosive things as well, like variable stars. Now, there are different types of variable stars. Stars that change in brightness over time are called variable stars. And there's two primary types. You have intrinsic and extrinsic. Intrinsic variable stars is something within the physical structure of the star that's going to cause it to change brightness over time. And extrinsic is something outside the physical star itself that's going to cause it to change brightness. So with intrinsic, we have the pulsating stars, where the stars literally themselves pulsate. You got your Cepheid, your R Lyra, your RV Tauri, these long-term variables like your Mira. You got all those you can go into. You've also got your eruptive or cataclysmic stars. These are things like your supernova and your nova, your supernova imposters, your current nova. These are things, it's something about the star, but it's not like a regular pulsation. It's more eruptive, more cataclysmic. The extrinsic types of stars are when something is happening outside the structure of the star itself that's making its light change. And in general, there's two types. Rotating variables are basically stars with giant sunspots on them. And as they rotate, the side that has the sunspots is not going to be giving off as much light. The other type are eclipsing binaries. And these are when you get the two stars. These are when you get the two stars moving in front of each other or behind each other. This is the stuff that I studied when I was doing my degree in astrophysics, what became my master's degree on transiting exoplanets. As one small star moves in front of the big one, it dips the overall light curve of that. So we've got examples of these within cultural traditions of the world. And what I want to do is talk about how looking back at both written and oral cultural traditions from cultures around the world can help guide modern astrophysical practices. So in that context, astrophysicists, we have our eyes to the skies. We're doing lots of large-scale surveys using survey telescopes, and we're picking up all kinds of transient events. We have to go through, catalog them, analyze them, sort them, and figure out what's interesting, what's not. And a lot of things are quite interesting in that regard. So there are going to be lots of variable stars of different types, and I want to talk to you about some oral traditions that describe stellar variability with a focus on here in Australia. So one of these stories comes from the Coorong, the area down south of Adelaide. The Ngarrindjeri people there's a number of different narratives that talk about this man called Wayangari. Wayangari literally means the red man. And this is an initiate. So the story was there was an initiate, mid-teens, who was going through his initiation phase. And part of that is that he had to prove himself both intellectually and physically. the physical aspect of this meant that he had to go for about a week or so on his own, out away from the community, away from everybody else, and prove himself. He wasn't allowed to wear any clothing. He had to fast the whole time. He wasn't allowed to have contact with anybody else. But the whole time, he was covered from head to foot in red ochre, hence the name Wayangari. Now, there are different narratives of this story depending on the communities, but some of the communities talk about how Wayangari one day was drinking water through a reed as a straw, and as he bent down to drink water near this river, some of the ochre fell off into the water and washed down shore. And down shore, two women saw the ochre in the water, and they were wondering where it came from. And they sort of snuck around, and they saw Wayangari, and they thought that he was quite attractive. They followed Wayangari as he went back into his own little hut that he had built. And when he had gone in to sleep for the night, they morphed into emus and created sounds of emus, which, being the hunter he is, drove him outside. And when he came out to try to, spear the emus, they morphed back into beautiful women, threw their arms around him, and said they wanted to be his wives. And they went into the hut, and we'll let you draw your own conclusions about what happened there. Now, in the narrative, these two women were actually his sisters-in-law. They were the wives of his brother, Nepali. Now, this might seem a little strange to some people. How come he wouldn't recognize his sisters-in-laws? When you reach a particular age in a lot of Aboriginal cultures, certain parts of your family become taboo to you. You're not allowed to associate or link with them. That often happens between mother-in-laws and son-in-laws, and it also happens across sort of, siblings with in-laws. Now, news of this got to his brother Nepali, and Nepali became very angry about this, flew into a fit of rage, and tried to set the hut on fire that they were in. They woke up in time, running outside, realizing that they were facing death as a consequence. They began running down the river and decided their best chance of escaping death was to go into the sky. So Wayangari casts a spear into the Milky Way, pulls himself and the two women up, and he pulls his canoe behind him. He becomes a bright red star in the Milky Way. The two women become these whiter stars flanking him on either side. And he pulls his canoe up into the sky, which can be traced out as a beautiful constellation, with the celestial emu off to the east. And as these stars rise and set throughout the year, they indicate changing seasons and the behavior of plants and animals. Now, when this particular group of stars is high in the sky just after sunset, when it's culminating, when it's sort of crossing the meridian, highest point in the sky after sunset, this signifies that they're starting to come out of the depths of winter. They're coming into what we think of as spring, and there's a rejuvenation in the air. This means that the animals are coming into season, and the traditions talk about how Wayangari in his celestial canoe can be seen sometimes getting hotter and brighter. And he's sort of getting hotter and brighter over time, and that later on that will fade again. But when it gets hotter and brighter, it's signifying to the people that his passions are on the increase, and it's meant to be a taboo relation story to people, that they recognize that, and it reminds them about the traditions and the taboo he broke, and to control themselves and do the right thing. So there's a moral narrative. There's a whole lot more to that story. I'm just giving the bare bones version of it. Now, early anthropologists, when they began looking at this story, because most anthropologists don't know much about astronomy, fair enough, they misidentified the star in question. And they said, it must be the planet Mars. It's bright and red, must be Mars, right? And for a long time, they couldn't quite figure out who the two women were. And they even went to an astronomer and said that this story is talking about Mars. Who were the two women? And the astronomer, the government astronomer, Dodwell, said, well, maybe there are two planets coming into conjunction every once in a while, like Venus and Jupiter or something. And he didn't really know. And it wasn't until probably about 2018, I think it was, that an anthropologist colleague of mine sent me a paper he had written pulling all these stories of Wayangari together, and he wanted my opinion. He said, I don't think that this makes any sense. I don't think that this is Mars. What do you think? And I started going through the stories and looking it up and studying, and it was obvious what it was. I think most everybody in the room or watching would know who it is. What's a bright curve of stars high in the Milky Way, around August and September, sort of coming out of winter with the Emu off to the east, a bright red star flanked by two other white stars. It's the star Antares. And Tau and Sigma Scorpii are the two wives, and Scorpius is the canoe. You find this all across the Pacific and even Australia. It's a very common motif to see that described in that way. So what's interesting is they're talking about this star changing in brightness over time, right? They thought it was Mars. It's not Mars. It's the star Antares. But Antares itself is a variable star, and it changes by well over a magnitude over the course of about 3.5 years. So there seem to be traditions talking about this star changing in brightness over time. Now, it can be a challenge to observe variable stars, as I think most of you would recognize. But there's some things to consider. Firstly, if you're going to notice stars changing in brightness over time, you need to have some comparative stars around by which you can judge changes in brightness. A star off on its own, like, say, Canopus, for example, might be a bit of a challenge. There aren't a lot of bright stars around Canopus in the sky. But if you look at something like Antares, there's lots of bright stars around through which you can tell whether the star is getting brighter or fainter. And it can change by well over a magnitude over the course of a few years, something that you'd be able to notice if you keep close attention to the skies. There is another tradition that's part of the Seven Sister song line that goes from coast to coast across Australia. It talks about Wati Niru, some places Nairuna. It's the man in Orion who is in constant pursuit of the sisters of the Pleiades. Now, there are a lot of early colonial records that talk about this figure in the sky, whether it's in the Central Desert, whether it's over in New South Wales, whether it's in WA, talk about this group of stars representing a man, Orion, in the same orientation as his Greek counterpart. What that means is the traditions specifically say, many of them, that he's upside down in the sky. Even early Daisy Bates talked about how curious that was. They would describe him as being upside down in the sky. And we think of certain parts of Orion, like his scabbard. The scabbard of Orion was not described as a scabbard until about the Victorian era. It was described as something it kind of looks like to most of you if you look up and see a man up in the stars. And that's exactly how the Aboriginal communities would talk about that. So the story is that he would be chasing these young girls, the Pleiades. They didn't want to have anything to do with him, but he wanted to make the youngest girl one of his wives. Their elder sister got sick and tired of his behavior, and she's represented by the stars in the Hyades, that V shape of stars. And she would continually draw attention away from her sisters and to herself, and mock Nairuna. And she would, taunt him and just do whatever she could to get his attention away from her. And this would anger him to the point where he would create fire magic in his right hand, the red star Betelgeuse. And he would try to cast fire magic at her to get her out of the way. Well, she wasn't taking his crap. She would create fire magic in her left foot, which is the star Aldebaran. And she would kick sand back at him. She would kick this fire magic back at him, which would humiliate him, and his fire magic would die down again. And this cycle keeps happening. He would come back again brighter, but this next time, she called on Baba, the father dingo, who came in and started shaking Orion, while the other stars around twinkled in laughter and humiliation at Nairuna. It was stories about appropriate behaviors, story about what it's okay to do and what's not okay to do. And there are lots of stories that are embedded within the landscape all the way across the country with the song line, literally a navigational map across the country that's encoded in song that tells you where everything on the land is, that's mapped out as a reflection in the sky. But if you look at the scientific elements of this, you've got the diurnal motion of Wayangari chasing these girls across the sky. You've got the bright group of stars between him and the young girls forcing away. You've also got this idea of the fire magic. using the two red stars. Now, only about 3 to 4% of visible stars in the sky are noticeably red. They're quite rare, as stars are, and those tend to have more special significance within indigenous cultural traditions. So they seem to be describing a variability of not only Betelgeuse, but of Aldebaran. Now, Betelgeuse changes by over a magnitude over the course of about 400 days. There's a couple of different cycles within its variability, but the primary one over a full magnitude takes course a bit over a year, about 13 months or so. And again, lots of comparative stars around by which you'd be able to notice that. But it also suggests that you are going to have Aldebaran also changing brightness over time. Now, our light curve data of Aldebaran is quite incomplete, and it doesn't go back a very long ways. There are periodic changes in the brightness of Aldebaran that, well, I shouldn't say periodic. They're definitely, if anything, semi-periodic, but they're almost kind of somewhat random, where it'll go through a bit of a change in brightness by a few tenths of a magnitude. The minimum you need to be able to see is about 2/10 of a magnitude. It can sometimes be a bit more than that. But if you look back on that, it indicates to us that perhaps, we don't know, but perhaps Aldebaran has a strange kind of behavior, that there could be more to its variability than our relatively short time periods of scientific data can tell us. That maybe there's some long-term variability, maybe there was some more variation in the past we don't know about today, but it brings up a topic that's worthy of investigation. Of course, when I brought this research up, there were some people who said this is rubbish. People can't observe the variability of Betelgeuse, whatever. But, in 2019 and 2020, Betelgeuse demonstrated for us a kind of rare form of variability. It wasn't its periodic form, but we went through the great dimming of Betelgeuse, where it became noticeably fainter. I think everybody would have been able to go outside and see how much fainter it was if you had taken time to go out and see it. It's pretty amazing. So here's just some light curves of Antares, Betelgeuse, and Aldebaran to show their variability changes over time. So there's ways we can look at these stories, and that can inform us about stellar variability that we might not normally be looking at. I mean, nowadays, we've got lots of telescopes observing stars all the time, and we're finding all kinds of variable stars. My exoplanet research, there's tons of them out there. That just becomes mundane after a while, to tell you the truth. But there's always some interesting ones there, and I think that further investigation of Aldebaran could be a really great way of understanding that. We can look at classic examples of stars like Algol, the blinking eye, or the winking eye of Medusa, and the constellation Perseus. And back in 1783, John Goodrick had sort of figured out that there's something strange happening with this system. It's a transiting binary system, and when the smallest star moves in front of the larger star, the smallest star moves behind the larger star, it drops the brightness quite a bit. Sorry, it's the little star when it moves in front, dims it. But anyway, it caused the brightness to change quite noticeably. And that can happen over several magnitudes. In some cases, Algol dips just a little bit by a bit over magnitude. I forget the exact amount it is, some relatively small amount, but it comes back up over a period of just a few hours. So if you're paying careful attention, you notice this. And in ancient Egyptian records, historians had managed to find records of this describing it. But curiously enough, there were multiple descriptions of this star winking over time. And when scientists went back and looked at these ancient records, they found a particular pattern in when this was happening. And doing a basic kind of Fourier analysis of this, they were able to recognize something quite exciting, that they were actually able to time the transits of Algol and realize that longer ago, they were occurring more quickly than they are now. Now, the scientific data shows that these two stars are actually moving away from each other. And this was one aspect of this sort of interdisciplinary research between ancient history and modern astrophysics in the world of cultural astronomy, where you can actually show that ancient records of these stars show nowadays that these stars are moving apart. We can see the change in that over time. That helps constrain physical models of these systems. So there's interesting ways in which both written and oral traditions can help guide modern astrophysical practices. So those are some examples of variable stars as far as the intrinsic pulsating types or even the extrinsic eclipsing types. What about the cataclysmic types? And this ties in a little bit more to the stuff that we're doing in the world of transient astronomy right now. A somewhat well-known example of this was a paper that I published back in 2010 with a colleague named David Frew at Macquarie. He was an astronomer. And we went back and looked at these old traditions that were recorded from the Burong people, Burong meaning night, from up near Lake Tyrrell, where you had the Lake Tyrrell Star Party. Interesting fact, a lot of people know that Tyrrell means space, sky, stars, right? Because you can see the stars reflected in the lake. The Burong people prided themselves on being the best astronomers around. They prided themselves on their astronomical prowess and ability. Burong means darkness. They were the nighttime, the darkness people, and darkness in the context of nighttime. They had shared information with William Stambridge over a few years, and he wrote a 4 or 5 page paper in 1857 that gave just kind of a laundry list of stars, what their little description was and what their counterpart was. But one in particular line in that, he talks about Wa, the male crow, Wa being the onomatopoeia for the sound a crow makes, being the star Canopus, being the brother of Warpil, the eagle, and was the first down to bring, fire from Tyrrell, space, and gave it to the Aboriginal people. But also talks about Cullagaloic Wa, which Cullagaloic basically meant the wife of. Describes a large red star in Verbal Carol, marked 966, was the wife of Wa. All the small stars around her are her children. And we decided to research this and unpack this. Both of us worked in variable star astronomy, and as we began unpacking this, it was very clear what was being talked about. We had some descriptions of this. It was large, so bright is what they meant, red in color, in the now defunct constellation of Robert Carroll, which is now part of, Vela and Carina, that area, marked 966, so a catalog number. Now, back in the 1800s, there were not a whole lot of different astronomy catalogs like we have nowadays, right? And described it as being a bright star that seemed to be surrounded by a bunch of fainter stars, smaller stars, right? So when you start looking at what he's talking about, he's referring to these stars in the constantly, Robert Carroll became defunct, that it became Argus, and starts looking at that and realizing there's something there that wasn't really in the catalog, and he had a difficult time trying to make sense of that. It was the star Eta Carina. You can actually see it right here on the thing. It shows Eta, right? He picked up the nebula that it was within. And if you go back and you look at the light curve of Eta Carina, it went through a great outburst in the 1800s, really around the 1840s, right at the time that he was there working with the people. So you would have seen, it would have been a rather fairly mundane and significant fourth magnitude star for a long time. Then over a relatively short time grew to be extremely bright, second brightest star in the sky, brighter even than Canopus, before rapidly dropping in brightness to the point of invisibility. So this shows the time period that Stambridge was up there learning from the people. And that red line is a rough approximation of the limit of human visibility under most conditions. So Eta Carina, shed its outer layers over 20 solar masses. It shed these outer layers of this, super giant blue variable star. And when it shed those outer layers, it pulsated basically as it shed them out like a supernova in Postry. It became very bright. But as those clouds, as that debris went out into space and expanded and it cooled off, it was like dust getting in the way and it blocked all the starlight. And that's why it dropped so suddenly, so rapidly over the next few decades, to the point where it wasn't even visible after a while. So we had managed to do research on this and show the Aboriginal people were talking about the great eruption of Eta Carina as it was happening. And there were other cultural traditions within the stories that gave the same indication. The idea that stellar spouses were always stars nearby in the sky of similar magnitudes. That's just the mode of how that worked. And Eta Carina would have been quite close to Canopus in the sky. They both would have been the most, second and third brightest stars in the sky. They would have been very prominent. This is the only indigenous record that we know of anywhere in the world that describes the great eruption of Eta Carina. It not only tells us that people noticed these things, but they incorporated it into their oral traditions in real time as it was happening. It also tells us something that we already know, that indigenous knowledges are dynamic. They're not static in time. New information comes in that informs those traditions, and that's a really powerful way of understanding that these oral traditions can be a pretty phenomenal record, going back thousands of years, potentially much longer than that, tens of thousands of years, potentially, of careful observations about the sky. And we can learn a lot from that. The last bit, because we've only just got a couple more minutes, is I wanted to talk about another example of a potential supernova observation described in Aboriginal cultures of Eastern Arnhem Land. So this bark painting is telling the story of these two brothers, the fisherman brothers. These two brothers went out on a fishing expedition and out at sea, and they had been warned by elders to be careful and not really go if they could avoid it, because at the time of the year they were going out, even though it looked beautiful and clear that day, storms can appear out of seemingly nowhere. It was a very dangerous time to be going, but the brothers decided they were going to go fishing anyway. They became so enthralled within fishing that they weren't paying attention to what was happening on the horizon. Storm clouds were gathering, and by the time the boys recognized what was happening, they could see the storms were moving in. It was becoming a very serious situation. They began paddling back to shore as fast as they could, but they weren't fast enough. The storm overtook them, the waves capsized the boat, and the older brother, being stronger and more experienced, saved his younger brother at the expense of his own life. After the storm, some community members found the younger brother lying on the shore. He was barely alive, but he was alive. And they went down, they found the broken canoe, and they asked the younger brother where his older brother was. And a little while later, they found the older brother's body. He had died. He had drowned. Now, the community, to celebrate the heroism of the older brother, because the younger brother explained to them that his elder sibling had saved him, that they decided to hold a ceremony in his honor. And the story says that a couple of days later, a bright new star appeared on the sky banks, or on the banks of the Sky River in the Milky Way. And that was the older brother telling them that he was safe with the ancestors. And later on, years later, when that younger brother grew to be an old man, he wanted to join his brother in the sky. So he asked the sky ancestors to take him up. And they became the stars Shala and Lasath and the stinger of Scorpius. So there's some interesting elements about this story. It's clearly talking about the galactic bulge. It gives you an indication of where it is in the sky. It even shows here on the bark paintings describing the story. This is very clearly the galactic bulge, right? So a bright new star appearing in the sky. Well, if the star was still there when the younger brother grew older, why didn't he join the brother in the sky where that star was? Well, he couldn't, because the star wasn't there anymore. But it does describe a good indication of the two nearest, two prominent stars that are in the tail of Scorpius, Shala and Lasath, where the older brother is the brighter star and the younger is the slightly fainter star. Now, curiously, when we begin looking at these records, we realize this is a story, and it could just be a story that's not talking about an actual witnessed event. It may just be an allegory. It may be a symbolic story, right? But curiously, when you go back and you look at supernova records over the last couple thousand years, one of them jumps out very prominently. And that's the supernova of the year 393. In the year 393, the Chinese records, the court astronomers recorded this supernova right on the banks of the Sky River. By the banks of the Sky River, what they mean is the dark spaces in the Milky Way represented the river. The banks mean it was on the edge of the bright and the dark space in the Milky Way. It occurred right in the middle of the galaxy and very close to the stars Shala and Lasath. Now, the Chinese records talk about when this supernova was visible, and it was visible at the exact time of the year that's described in the stories. Now, is that proof beyond positive that these communities observed the supernova of 393? No, it is not. But there is quite a bit of evidence on a number of different levels indicating this could be a very reliable source for that particular supernova remnant. So there are lots of examples of supernovas that have occurred throughout history that have been described in both written and oral traditions. And the written traditions, particularly those of cultures in like China and Korea and Arabia, have become an invaluable resource for astronomers who are looking for counterparts that could explain the supernova remnants they're finding that indicate very young events, things that may have occurred in the last 1,000 or 2,000 years. So by working with elders in communities, we could potentially find stories or learn about stories that describe these events appearing in the sky, telling us possibly where to point our telescopes, or vice versa. There could be supernova remnants that are discovered by astronomers, which have happened quite a bit in the last few years, that indicate the supernova would have occurred fairly recently, maybe within the last 10,000 years, and they're curious if there are any stories that describe that. So there's a lot of ways in which we're sort of bringing together these ancient written records, the ancient oral records, modern astrophysical research to see what kinds of ways that we can find interesting intersections within that world. How can they inform each other? How can we learn from that? But also it's a bit about systems research. When you talk about how things are integrated and how things work, elders talk about a lot of exciting philosophical and ontological and epistemological frameworks that could be utilized and adapted by the astrophysics community. And these are the things that we're very, very seriously looking into right now and taking on board. So there's a huge amount of capacity for the astrophysics community to learn from and alongside elders and indigenous astronomers around Australia. That's some very exciting research that's happening right now, and I'm really happy to be a part of that. So I'm going to go ahead and finish there. If you'd like to learn a little bit more about this, you can pick up a copy of a book I published a couple years ago called The First Astronomers. All the book royalties go to charity. I don't make any money off the book, so I don't feel guilty about flogging it, right? Co-authored with 6 elders, and it's really about the science of indigenous knowledge. So thanks, Mark, and thanks everybody for having me on today. I really appreciate it.
You are welcome, Dwayne. Thank you for a very interesting talk. Got a couple of questions for you on the chats. Also, we've got that book at our library, the ASV library. I think we've got a couple of copies of it. So, Kate has a question. In Indigenous culture, there are song lines for each mob and shared song lines for meeting of the mobs at particular points. Is there any indications of shared astronomical knowledge between the mobs?
Oh, yes.
Really cool question.
Absolutely, 100%. A lot of these song lines that spread over long distances often incorporate different languages. Like when you get to the new country, you'd be singing the new language. Those song lines are mapped out in the stars, right? So one of the interesting realizations that we had learned working with elders is the elders would talk about these travel routes. They would do traditional travel routes and traditional song lines. So if you were going to travel from point A to point B over some long distance, you had to figure out the best route to get there, right? And as you're on your journey, you got to know where to stop, to camp out, where's the food, where's the water, where's the medicine, and you need some landmarks to help you out, right? So when you figure that out and you need to teach the new generations how to do this route, how are you going to do that? You don't have a portable map. What you do is you pick earlier in the year at night, you pick stars in the sky that act as waypoints on that journey. So you kind of pick a constellation of stars that has a similar shape to the journey you're going to be taking. You create this oral map through song, and you teach the younger generations about that. And the stars serve as waypoints on your journey, and the whole thing is meant to be a mnemonic. It's meant to be a memory aid. Later on, when you're not traveling at night following the stars, second star to the right, straight on till morning kind of thing, right? You're literally traveling during the day, but you had learned it as a mnemonic aid. So what you find is that when the colonists first started going across Australia, in some cases, they'd be shown the same pathways by Aboriginal people. In some cases, they'd see these well-worn paths, whether the people told them about it or not. They'd follow the same routes, which became roads. They'd camp at the same places, which became towns. And over time, what you find is the song lines and trade routes became the network of highways and towns across Australia, which are all mapped out in the stars. And if you take the constellations of stars and scale them and put them over top of Google Maps, there's this beautiful correlation how they map out. So highway and town networks are laid out around Australia based on star maps. And you'll see that even if for anybody who might be going to Sydney, if you're going through the Blue Mountains, that main highway follows an old Seven Sister song line. But there are lots of similar traditions around Australia when it comes to astronomy. Some of that shared knowledge about that, and some of it's just describing physical things that happen in the sky, like how to read twinkling stars or what a moon halo is going to tell you. And the reason that they're so similar is because they're based on physics, and physics is the same anywhere you are.
That's a wonderful answer, Dwayne. I actually travelled that Blue Mountains Highway last week, so yeah. We have another question here. Dwayne, are you aware of any cultures that may have used star or constellation shapes for language characters or pictographs?
That's a good question. I'm not sure. Probably. I mean, I can see lots of representations in art that describe astronomical things, and some of them were almost like a written language. So some of them would be like message sticks. And message sticks would be something you would take to somebody, a neighboring community about a ceremony, and it would have depictions of the rivers where they're crossing. That's where you're going to hold the ceremony. It would tell you there'd be a figure of a human doing something that tells you it's going to be an initiation ceremony, and it would have two moons. One moon of when the message was sent, and one moon of when the event was going to happen, which would usually be separated by a few weeks. So you could see representations of astronomy in that, encoded as bringing together space and time. This is something that I teach the students in my class because the elders taught me, and it's something all of us know. You cannot separate space and time. They're completely intertwined. In indigenous knowledge, space and time are just two sides of the same coin. Exactly the same thing we know from Einstein's relativity. Space and time are intricately interlinked. But yes, you're going to find amazing similarities across different cultures, and that's something I talk about a lot in the book.
And one last question, unless someone else throws another one at us. Is there any evidence in Indigenous astronomical knowledge of tracking repetitive comets such as Halley's Comets?
Yeah, that's a good one. I don't know. I've looked at that. There seem to be some indications potentially of meteor showers that were described. I think there very well could be. I don't know of any that I can point you to, but when it comes to studying indigenous oral traditions about stuff, it'd be like me going to Port Phillip Bay and putting a glass of water in there and being like, the glass of water is the stuff that I've been able to search so far. All right, there's tons of stuff out there. Yeah.
So we know as much about that as we do about what lies beneath the ocean.
Yeah, really. But there are, there's, even though people would oftentimes describe seeing comets as omens or being surprised by them, people still knew what they were to a degree, and they recognized them. And there's lots of cultural traditions and ceremonies tied around eclipses that were predicted in advance. That gives you some kind of indication of that. But yeah, comets, I'm not entirely sure about cycles of repetitive comets, but I wouldn't be surprised, but I don't know the answer to that.
All right, well, wonderful. Thank you very much, Dwayne. Oh, hang on, we have another question. Oh, we got two more questions. We're going to do the last two questions.
I'll be quick. Sorry.
All right.
Too long.
No, that's okay. They don't want to listen to me give Bill's talk anyway. So, are there any stories related to SN 1054?
Supernova 1054. Probably. I mean, there's no way you're going to tell me cultures that paid very careful attention to the sky didn't notice one of the brightest supernova in history, right?
Yeah.
100% people would have seen that. That doesn't mean that I can identify a clear example of that, because like I said, I haven't had a chance to go through all the stories or anything yet. It'd be almost impossible to do. But yeah, it's a really good question. These are things we're going to be looking at more in depth over the next few years, because with these major grants come PhD students and postdocs who are going to be deep diving into all that stuff. I do want to say quickly before we finish, the petroglyph of the 1054 supernova down reported in Arizona within the ancient Anasazi, ancient Pueblo, is almost certainly not of the supernova of 1054. It is 99.99999% chance that that's referring to the crescent moon and Venus, which is a very common, very powerful motif in that area and around the world. In fact, the very first paper that talked about in an edited volume that representing the 1054 supernova, the very next paper completely took it apart. Nobody paid attention to that second paper, but everybody grabbed the first paper and ran with it. So I just want to put that out there.
I've got last two questions. So here we go. We've got what is the next stage with your research? So where to from here?
There's so much more to do.
The world is your oyster, Dwayne.
So much more to do. I've got a whole team of PhD students working on various projects in this space. I've got some who are looking at microsatellites and light pollution and dark sky tourism and how that relates to indigenous astronomy. I've got students who are working in the Torres Strait, picking up on my work where I never have time to do any work because I'm always writing grants and doing admin. I've got students who are on board working with the Kulin Nations around Melbourne, so that's a huge project we've got coming up. We're doing some major research projects between the space sector and indigenous communities and how we can help facilitate more dialogue and engagement and reciprocal benefits between them. I've got students coming in working with communities in the South Pacific, particularly Vanuatu, New Caledonia, and the Solomon Islands. Franco-speaking student, which is good. So there's a lot of research projects happening. There's never a shortage of things to do, right, in this particular space. There's more communities to work with. There's more exciting stuff to dig into. You know, all these questions I can't answer now. I don't know if I'll ever be able to answer them, but we're certainly going to try to find out.
That's half the fun of work, isn't it, in your field?
All the fun I love doing. The not fun part is doing all the admin and grant writing.
Last question, and I reckon I can answer this one. Andrew Hayes is one of our section directors, and he wants to know, he works at RMIT, and he said wants to know if he can come up and get you to sign his copy of The First Astronomers. My response to that will be, Andrew, next time that Dwayne and I catch up for a beer, I'll let you know, and you can come and hang out and have a beer, and Dwayne will sign your copy. How does that sound? That sounds pretty good. Yeah, 100%. There we go. Look, the amount of people who have loved your talk tonight, Dwayne, thank you very much for coming along and giving us this wonderful presentation. It's been very interesting to listen to. And it's a topic that we know is somewhat controversial, but has a lot of merit. And through your work and your students' work, more and more information is going to come to hand. That's for sure. So,
there's a huge body of work. A lot of people are in this, and I can guarantee you there is no way the School of Physics, the University of Melbourne, would have me here doing this research and teaching if they didn't have a pretty damn good idea that what I'm doing is legit, right?
There you go. Excellent.
Put that out here now. All right.
Yeah.
Thanks so much, Mark.
Thank you very much for coming along, Dwayne. And I'll see you soon, no doubt. And I'm going to pop up Bill Stent's What's in the Sky and read through that as if I know what I'm talking about, which I don't, and share with everybody what is in the sky for. We're going to try and add that to stages. Hang on, I have to remove yours. Here we go. Share that, and I'll work through that. But Dwayne, thank you very much for coming along tonight. I know you're a busy man, so I'm going to let you go. You can run off and you can head home now because I know you're still at work. But yeah, again, thank you very much for coming along and presenting for us.
Thanks, Mark. Appreciate it.
See you later. All right. Let us have a look at what is in the sky for April, late April, and early May. I know I am not Bill Stent, the telescope gent, and I'm definitely not the next best thing, but we will pretend that I am him in AI. Let's roll through this. Tonight, as Bill would normally say, we're meeting on the lands of the Bunurong and Wurundjeri people, or Wurrung peoples of the Kulin Nation. The general conditions at this time of year, he hasn't told me, so I'm reading straight from his. So just so you know, Bill's got COVID. He's not feeling very well. He sent me a photo of himself rugged up under blankets and said, "Can you do the talk? I've got COVID." He's going to cover off what's in the sky, where's the moon, the planets, getting orientated, suggested targets for tonight, not just for tonight, for this month and early next month. targets for the early risers, and a little bit about the Eta Acrids and things to look out for this month. So the general conditions at this time of year, well, there you go. He's going to tell us about them. I'm going to tell you about them. Welcome to the Eastern Standard Time. Remember, if you have a go-to mount, which most of us do, or quite a lot of us would, don't change your hand controller time zone. Just switch back from daylight savings. That will do the trick. That's something that I'd absolutely personally had forgotten all about. And when I set my gear up tomorrow, I will be doing that. Solar transit in Melbourne is about 12:22 today rather than 1:20 last week. We're approaching winter now. We are past the equinox. And in Melbourne, it certainly feels like we are approaching winter. In fact, my car today said it was minus 40. Winter is more associated with galaxies, although Bill is not sure it's valid. I'm going to disagree with you, Bill. What about dew control? Oh, Bill, that photo. That is some pretty bad dew control. Hand warmer pads bought from pharmacies. Hot hands, people. Hot hands are great, not just for your dew control, but for your temperature control in cold weather as well. Hot hands have saved me through very many winter nights in freezing temperatures. You can even get the ones for your feet as well. A hairdryer if you're at home. And he is right. If you are up at the Liam Our Dark Sky site, do not plug a hairdryer in and try to defrost your telescope. We do not like that. Electric warming straps or dew heaters, they are your friend. Sunset tonight, which has been and gone, was at about 6 p.m. It was dark at about 7 o'clock. And next month it will be sunset at 5:25 p.m. And sunrise tomorrow morning will be at 6:40 a.m. and it'll be dark until 5:25, although most places it's cloudy, so nobody's going to be doing any astronomy tonight. Next month it will be 7:05 a.m., Bill. A.m., not p.m. For the, I am not even going to try and pronounce that word. For the moon lovers, I'm tipping. Full moon is on Sunday, April 13th. That is this coming Sunday, if I am not wrong. In the south over next week. So it's in the south over the next week, so it'll be high in the sky. It's right on its maximum distance, so it's a mini moon. And over the following week, it's setting in the early morning as a waning gibbous. The last quarter is on Saturday, the 21st of April. As deep in the south now, so it'll be very high in the sky, moving back over the course of the week. It rises at midnight, sets at noon. Then over the following week, it will be a waning crescent. It'll get thinner and harder to see as it approaches the sun. View in the morning now, later this week in the early afternoon, then before sunrise. The new moon is on Monday, the 28th of April, which makes the Anzac long weekend a wonderful weekend for astronomy and for the Mildura Star Party. Subtle plug. In the north, so it'll be low in the sky again, but you won't see it. Able to see it in a few days as a waxing crescent after sunset. Look west. The first quarter is on Monday, the 5th of May. Rises at noon, sets at midnight, best viewing. Then following week is a waxing gibbous. Starts in the north, but crosses the equator on the 8th. No lunar X month this month as it's below the horizon. Oh, Bill will be devastated. The planets over the next month, these are from the ASV yearbook. Watch for Mercury, Venus, Saturn, and Neptune. Let the stampede begin. Mercury, now a morning object, maximum elongation on the 22nd, rises at about 4:55 a.m. Venus is another morning object, hanging out with the party bunch. Bill, you're a funny man. Rises at 4:55, same as Mercury, but slightly further north. Mars is getting old. Let's not have age jokes, Bill. Definitely an evening object, rising well before sunset, setting around midnight. Jupiter is continuing to move ahead of Mars and sets at about 9 p.m. behind the trees for the Troughton Sims. The Troughton Sims, that's at Melbourne Observatory. It's not as good as the 12-inch Mercer, but still viewable in twilight. Just so you know, the Mercer would be able to see that at 9 p.m., unlike the Troughton Sims. A little bit of a demonstrator battle going on there. Saturn, now a morning object, just getting in twilight, rises at about 4:45. We need photos of the closed rings. We do. Anyone who's got any photos of the closed rings, let us know, please. We'd love to see them. Uranus, pretty much a daytime object now, rises about 9:45 and sets at about 7:45 p.m. Neptune, another morning object along with Venus, Mercury and Saturn, and rises at about 5:10 a.m. Pluto, it's not a planet, Bill. Why is it in here? Now an early morning object rising at about midnight. Now we're going to be getting orientated with the sky at 10 p.m. facing south. So we have the Southern Cross at about 11 o'clock, high on in the southeast, which is there. We have Orion setting in the west, which is always good, but always bad. It's sad to lose Orion, but it also means there is another beautiful constellation rising in the east. Scorpius, which is rising in the east. Personally, it is one of my favorite constellations. There are so many amazing objects in there. Orientation of stars. We have our little clock here that Bill likes to use. Canopus leads the cross around the pole. Bacchanal is opposite the cross, low in the south-southwest. Sirius is bright and getting low in the west. Castor and Pollux are low in the northwest near Mars. It's quite a good view looking at those three in the night sky at the moment. Regulus is just past the meridian in the north. Speaker, I get told different names for that one. I'm going with Spica, is getting high in the east-northeast. And new this month, Arcturus is low in the northeast. Antares in Scorpius is low in the east-southeast. Do love Antares, it's beautiful. Planets, Mars is low in the northwest. That's right near Castor and Pollux. Jupiter is setting at around 9 p.m, so she be gone. Goodbye, Jupiter, for the time being. Bill's visual targets for the evening. Sky at 10 p.m. facing south. Jupiter, last chance. Very, very much so. Mars, double time in a few multiples. Okay, so we're going for Acrux, double star. Alpha Centauri. Sirius, difficult companion lost in the glare. Castor, a very low. Southern Albiro, he does like putting this one in. It is one of his favourites. It's a coloured double. Regor, Gamma Velorum, Delta Corvi, Beta Monocerotis. I will get that one right one day. It's actually a triple. Beta Scorpii and Beta Tucanae, which is low and very difficult if you're in a built-up area, that's for sure. Zeta Reticuli. Bill, did I say that one right? It's a bit higher. Apparently, you've got to watch out for aliens. I'm not sure why. He would have had a story for that, but I don't. So, photographic targets. These have come from Facebook. Sombrero Galaxy, it's a good target at the moment. Anne-Marie, that is a lovely image. Statue of Liberty has been a good one for a while now. And Gerald, that is one of the best Statue of Liberty images I have seen. We have the Dark Doodad. I do love the name of that one. Sam, as always, a great astrophotography. Southern Pinwheel, which was taken from the ASV's remote dome. The NGC 2997, which was taken by Mike Sidonio, Strongman Mike. Markarian's Chain from Rick Zhang. Herschel's Ray, Jacob Heppel. Centaurus A from the ASV remote dome. And Vesta Opposition is the 2nd of May. How about an image? No one's got an image. That's why I put that on there. If you've got it, we'll skip back, actually. If you've got an image of Vesta, share it with us. Sky at 5 a.m. facing south. The Southern Cross is now well past the meridian, 2:30 from the south celestial pole. And there it is there. Scorpius is just past the meridian at 5 a.m. The galactic core is close to the zenith. The planets, Venus is rising. Mercury rising. Jupiter Ascending is the movie. Saturn and Neptune are all rising. Oh, Bill. T Corona Borealis. Bill, it hasn't done anything for a long time, and I doubt it's going to do anything for a lot longer. But still, he persists in putting it in here. If anyone else can get some photos of T Corona Borealis for Bill, that would be great. We have sky at 5:45 a.m. tomorrow facing east. We have sunrise at 6:42. About a half hour after this, we have naked Saturn, bright Venus, Mercury, Neptune under the marker. So quite a lot of stuff going on there at the moment. The Eta Acarids, good this year with a favourable moon. The meteor shower is active from the 19th of April to the 28th of May. Dust from the tail of Halley's Comet and peaks on about the 6th of May. Plus or minus a couple of weeks, the moon sets at 12:40 on the 6th of May. At a dark sky site, it could be up to 40 per hour and look generally east after about 3 a.m. Go to LNDSS on Saturday, the 4th of May. Warm clothes, blankets, and a banana lounge. If you are an ASV member and you want to see something like this, the dark sky site is probably the best place to go. Final notes, random observations. At 22nd of April, Mercury is its greatest elongation, good morning viewing. On the 28th of April, Venus is at its brightest with morning viewing. 2nd of May, Vesta opposition Mag 5.4. 4th of May, best date for viewing the Eta Acarids from the Leon Mao dark sky site. 6th of May, Pluto stationary retrograde starts. The astrologers are going to be out in force from the 6th of May. There it is there. And then it's coming back. Oh my gosh, Bill, you have done a lot of work. 6th of May, Eta Acarids meteor shower peaks look broadly east early morning. On the 10th of May, the moon and Spica east just after sunset, less than a moon diameter away, so nice and close. 15th of May, Juno opposition, Mag 10.2, so much less bright. T Corona Borealis, keep watching for a sudden bright star. Rises at 8:30, transits at about 1 a.m., sets at 5:45, so all night, but low. Bill, you will need to move on to another object soon because T Corona ain't doing nothing, buddy. Sources, Bill has put his sources in there and he thanks all of the ASV contributors, even though they don't know that they're going to be contributing. He just grabs them off there. And that is our lovely talk. I'll add myself back. I hope that worked. Where are we? I've lost control of my own screen. There we go. So hopefully that makes some sense. And we all got to see Bill's lovely talk of the night sky, tour of the night sky. And thank you again to Dwayne for coming along to present tonight. It was greatly appreciated. He's done a great job. And he always does a great job. So, again, thank you to Dwayne. Thank you to Bill for providing me with that presentation. And we will break that up into a What's in the Sky video that we will upload separately as well. Thank you, everyone, for coming along tonight. And hopefully next month we will see you in person as well as online from Mueller Hall. But for now, we will see you next time.